Please welcome back the Assistant Secretary for Energy Efficiency and Renewable Energy at the Department of Energy, the Honorable Dr. David Danielson.
All right, fantastic panel. So it's my pleasure now to introduce our afternoon keynote, Mr. Richard Kaufman. Richard was actually appointed in February of 2013 as the Governor Cuomo's he was the New York State's first energy czar. And in that role, he really oversees and manages New York State's entire energy portfolio, which includes the New York State Department of Public Service, the New York Power Authority, the Long Island Power Authority, and the New York State Energy Research and Development Authority, NYSERDA. He brings an amazing background to this position. He's a graduate of Stanford and Yale. He was a partner at Goldman Sachs, where he chaired the global financing group. He was the CEO of Good Energies, which was one of the most important, significant venture capital private equity investors in clean energy when he was the CEO there. And I got to know him very well when he was a senior advisor to Secretary Stephen Chu, where, Richard, you were one of my very favorite people to work with at the Department of Energy, period. So I had a lot of fun working with Richard and going through thick and thin, and I thanked God every day that he knew so much about finance to help us push things forward. If you look at, he's done a lot of very important things. I would argue that what Richard's done over the last 3+ years is the most leading, pioneering energy work happening anywhere in the country, if not in the world. And in addition to doing things like establishing the New York Green Bank and the New York Sun Solar Program, I think two very significant areas where we see major leadership here in New York under Richard's leadership and tenure. One is the REV process. This is the Reforming the Energy Vision Initiative, which is a big deal where Richard is really leading the charge in trying to envision the utility of the future, the grid of the future, where we are enabling more energy efficiency, we're enabling distributed energy to participate in markets so that we can get a secure, resilient, reliable, cost-effective, and sustainable grid. So the work going on here, I'd say, is second to none in that area. And especially relevant to what we discussed this morning, you may have noticed that half of the examples of US manufacturing scale-up stories in clean energy are right here in New York State. And Richard has played a huge role in leading the charge with the state of New York offering the right partnerships, the right economic development incentives to ensure that leading American manufacturing companies in clean energy are scaling up right here in America. So with that, it is my pleasure to introduce my good friend and colleague and a true American energy leader, Richard Kaufman.
Thank you, Mr. Secretary. And I just want to also acknowledge the partnership that I enjoyed with David. When I started at the Department of Energy, it was my first government job, so that was first level of difficulty of the dive. And the second thing was that the Department of Energy is a very technical place, a lot of science and technology there, and that's not my background. I'm a business and finance person, and I felt that it was going to be very tough to be in that kind of environment. And David, you were the first friend I had there and a great partner. So I really, really appreciate it. So I want to thank you, and I want to thank the Department of Energy, and I want to thank Deborah Wynn-Smith, whom I also met in Washington on the Council of Competitiveness, and I want to thank all of you for the work that you do. So I think I know there are people here from the energy area, and I know there are people that are not from the energy area, but I think all of us, even if we're not in the energy area, have this sort of feeling that there's a lot of great energy stuff that we could make in the United States. Solar, wind, fuel cells, power controls, solutions for making buildings more energy efficiency. The list goes on. We sort of feel like we've got a lot of capability that we could make this stuff in the United States, and that it would not only be good for those industries, but having these technologies be more broadly adopted by other companies would help the competitiveness of those industries as well. But it also feels, I think, to us that something happens between this great stuff that we could do and the market. We're hung up somewhere. So, where's the hang-up in between? So certainly costs are real. That's a hang-up sometimes. But I think that's often overstated, frankly. Some of the barriers to adoption are financial. And that's real, but I also think kind of overstated. There's plenty of capital to be put to work. Some of the barriers to adoption are frankly softer. So David mentioned I was the CEO of Good Energies. So Good Energies, we made an investment in a company that had a solid state, had a MEMS valve for air conditioning and refrigeration that had a 20% improvement, which is a big number in the air conditioning and ventilation world. A small company had this technology and even got the OEMs to agree that it could be a retrofit. Terrific. So a little company goes around, and where's it going to go first? Well, it's going to go to companies that use a lot of refrigeration and air conditioning. So they went to the big grocery store chains, said, we've got this great device. It'll save you 20%. Company really didn't make it. And the reason it didn't make it was because who did they go to? They went to the person that was the energy manager. They didn't go to the CEO. They couldn't go to the CEO on this kind of stuff. It was a little company, and the risks were asymmetrical, because if this didn't work, the person that would have made the purchase order would be out of a job. So sure, there was testing. Yeah, we'll buy a few of these things and see how it goes. But it just took too long, because this company needed to sell thousands of things, not dozens of things. And virtually every day, I meet with companies that have great ideas. They come to the state. And just last week, I met with a bulb manufacturer, an LED tube manufacturer, replacing in the existing socket a fluorescent tube with an LED tube. And they want to manufacture here in New York. They're currently manufacturing outside. They're having a hard time getting to market. Why are they having a hard time getting to market? Of course, it saves 95% of the energy, and it doesn't give off UV. It's a great product. Well, first, the existing distribution channel. There's a mature distribution channel, and this product doesn't fit what the distributors are used to selling. So the reason they came to us was not about a grant for manufacturing, but they said, well, maybe you could help us with the subway system in New York, because we use a lot of tubes in the subway system, and it will save the subway system a lot of money and energy. Okay, so that, but we've had a problem, because some of the savings also are that there's a lot of labor savings because we don't have to replace the bulbs. Great, let's have a conversation with the unions about that. So soft barriers are meaningful. So these barriers obviously can kill a small company, and they can even obviously affect big companies that if things just take too long and markets take too long to develop, it starves the ability for companies to commit capital to these opportunities. So what I want to do today is talk about two other barriers to clean energy. And when I talk about clean energy, I'm talking about both renewable energy and energy efficiency that are standing in the way of big deployment opportunities. And these barriers, as I say, are two. And the first is the utility business model and the government and regulations and policies that have helped create that business model. And second are government policies beyond that that have been used to support clean energy deployment. And I want to tell you that New York State is well underway in changing these policies so that we will have the effect of increasing market deployment. So to be really clear, government policies have been really effective for decades in terms of the grid. We built out a very complex electricity system that's developed low-cost, reliable power on a universal basis, and we have had traditional support programs to achieve some progress in advancing renewable energy. But the key thing is that we cannot afford to keep doing what we've been doing because business as usual needs to change. So I was working with David in Washington, and the governor called me after Superstorm Sandy, and he said to me, he said publicly, he'd been in the dark with a bunch of cold New Yorkers for days, and he said, you know, the utility industry is in the vinyl record age, in the age of the iPad. And he was talking about resiliency, but he wasn't just talking about resiliency alone, because the governor was also talking about the costs, the increasing cost of maintaining this traditional central station production and distribution system. And he was also talking about the way that customer preferences are changing to favor more distributed solutions. Customers want to have, and companies, individuals want to have more control over their energy. And he was also talking about the need to create economic opportunity that could come from a transition to a clean energy system. So the governor's plan, called REV, is designed to do exactly that, which is to build a system that's more affordable, more resilient, gives customers more choice and value, and creates more economic growth, and will be cleaner. And part of the governor's REV policy is the mandate to have 50% renewable power by 2030. So the question that people ask is, how are we going to do that on a cost-effective basis? And the answer is, and this is the good news, the really good news, and in particular I want to talk to people that are not in the energy business because you won't believe some of the things I'm going to tell you. The good news is the current system that we have, the current power system, is not only energy inefficient, and when I talk about energy inefficient, you know, a big power plant, sometimes half the energy content goes up the chimney in the form of heat. But it is financially inefficient. And I'm going to say this again. The current system is not only energy inefficient, it is financially inefficient. And so we can use the cost envelope of the existing bill to build a new system. So I'm going to give you quickly two examples of what I mean by how we can do something that's cleaner and cheaper at the same time. So think about a hot summer day. Okay, the system is built so that all the electronic devices, all the electric devices that you have can go on exactly at the same moment. Now, they don't all go on the same moment, but refrigerator, washing machine, air conditioning, they all go on. They can go on. It doesn't have to be that way. We know that there can be devices in each of these appliances that could cycle them on and off, and we would never know the difference. And it's really expensive to deliver peak power, and that power can sometimes be the dirtiest power. So the result of that kind of new system would be a system that would be cheaper and cleaner. Another example, we've heard many, many times about the intermittency of renewable energy. And it's true. You know, it's expensive the way we do it because we have a lot of fossil fuel backup. But if you think about intermittency and pairing intermittency, what could happen to the demand side, and to have the ability to vary demand with the intermittency, it means we wouldn't need all that fossil fuel backup. We could deploy more renewable energy. We wouldn't have to tie up all the extra capital in backup generation, and it would be a cheaper and cleaner system. So this requires a different kind of physical grid. You know, it requires that we stop rebuilding the grid of Tesla and Westinghouse, where electrons flow in one direction based upon fixed demand, which is really the equivalent of the IT system in the mainframe world. And we have to stop bolting on renewables and other distributed energy resources onto a system that was never designed for these resources. And that's what we've been doing. It's really expensive. And what we need to start doing is building a new system, which some of us have seen the pictures of many times, which looks like the IT system. It is a hybrid system. It has the cost and reliability benefits of the traditional traditional a central station production distribution system with the innovation and flexibility of distributed energy resources. That hybrid system is what the IT system looks like, and in that world, supply and demand are more variable, and electrons can flow in more than one direction. So the question is, why aren't we building that system? And this is maybe where I sometimes might have a good disagreement with David, because I think it's less about the technology. I always have to say it's less about the technology, and more about policy, regime, and regulations. So, and that's what we're changing. So I want to talk about some of the stuff that we're doing. Because the problem with current policies is just in the same way that the grid was not designed to do the things that we're asking it to do, the policy regime that we've set up was never designed to accommodate renewable energy or to be cleaner. So we can achieve our objectives by driving capital to build the system of tomorrow by focusing on two policy changes, regulatory change, and how we publicly support clean energy. So on the regulatory front, I said twice before that the current system is not only energy inefficient, but financially inefficient. I want to give you a couple of examples of what I mean. So the first example, and I think that some of you that are not in the energy business, but are in capital-intensive industries, are going to be surprised when I tell you that the average capacity utilization of the power sector in New York State is 54% and going lower. And if you go to Long Island, it's 44%. So it is built for the hottest days of the year or hottest hours, but we pay for it all year long. And there's a lot of capital tied up in the system. And when I think about my business career in the last 35 years, there's been a revolution, as it were, in improvement in capital efficiency across a bunch of other industries, from adoption of new technology, changes in financial incentives, and changes in business model. It has not happened in the utility sector. It's not happened in the utility sector because the way we pay utilities is through commitment of capital, not through the efficiency of capital that they deploy. So we can't be surprised that we have a system that's capital inefficient. We also can't be surprised that utilities haven't been as aggressive in making investments in technology as in other industries. Software is an example, or other IT may not be a capital expenditure, and therefore there is no financial incentive for utility to make those investments. There's no incentive for a utility to make an investment in storage if it saves capital, because there's less capital to be deployed. Second example, again, contrast this to other businesses. Utility profits are about 7% of a customer's bill. Represents the return on capital. Everything else, 93%, is a pass-through cost to customers. Now, I want you to think about your business where you would view the 93% as a potential wallet share. How can I reduce costs or increase value to my customers and earn some of that myself? That is not available for the utility sector until now. There is no incentive, therefore, to invest in innovation. So this is not a criticism of utilities. It's a relic of past policies that need reform. And one last point, if you haven't had enough of this. Utilities spend less than 2/10 of 1% of sales on R&D. Less than 2/10 of 1% on R&D. This isn't because there aren't great R&D opportunities that will result in financial returns. The reason that they spend only 2/10 of 1% is the regulators don't permit them, and the utilities can't earn the return that would result from those investments in R&D. So the utility industry stands in stark contrast to every other industry that's had to compete over the last 35 years in the global economy, where other industries have had to be capital efficient with an intense focus on cost competitiveness, and utilities get paid for committing capital and passing costs on to customers. And on top of that, to make things worse or better, depending on if you're thinking about the solution, the government adds a charge to customers on top of this already capital and energy efficient system to support clean energy projects in states that are bolted onto a grid that was never designed for them. So customers are paying twice for the same thing. And I'd observed that in many states, companies, rather than individuals, pay disproportionately to fund these programs. So we're increasing costs on companies. And then, to round out the story, then what government does to offset some of the costs that are charged to companies, it creates policies where government creates subsidies for companies to do energy retrofits. So we're changing all this under REV, and I'll give you two quick examples. So not far from here in Brooklyn and Queens, there's load growth. Con Edison would have to spend $1.5 billion on a new substation that would probably have 54% average capacity utilization. And instead, under our policies, Con Ed went out to the market with the problem and elicited from the market alternative solutions. And what came back was a range of solutions that included solar, CHP, storage, demand response, energy efficiency. So these alternative solutions, instead of costing over almost $1.5 billion, will cost $200 million. So all customers will save money because there'll be less capital deployed. There'll be less peak power purchased, so customers will save money there. And it'll be cleaner. So we know that this can work. We have lots of grid constraints in the state. We're under our new policies, deployment of storage, solar, and other distributed generation will be good not only for these customers, but for all customers, because these solutions, deploying these solutions in grid-constrained areas creates a pool of cost savings that can be shared between customers that use distributed energy resources, all customers, and the utilities, because we're operating under a financially inefficient system. So utilities now have a financial incentive to reduce costs and get paid for doing so. Utilities will have an incentive to help deploy distributed energy resources in certain locations where these solutions are cheaper than building traditional infrastructure. Utilities now have an incentive to work in partnership with DER providers rather than at loggerheads. And when we talk about costs, utilities can now work in collaboration with the providers to reduce customer acquisition costs, because soft costs are still costs. And you can see how we can create markets of scale for innovative clean energy products. So there's another example, just quickly, residential energy efficiency. 70% of the houses in New York State are more than 70 years old. So there's a lot of opportunity for energy efficiency. And so we will pay for somebody to come into your house, and depending on your income, pay for up to 100% of the cost of the retrofit. At the current rate of penetration of those programs, and when we say we'll pay for it, it's really coming from customer bills. At the current rate of penetration, it will take 500 years to retrofit the housing stock in New York State. And so one of the demonstration programs that we have going on, and these are demonstrations of business models, not technology, is turning energy efficiency into a business. There's a company called Sealed that's marketing their service to customers three ways: through comfort, and second, you don't have to put any money down, and third, we're going to guarantee you savings. And that's a pretty good combination. So the thing about this approach is that it's a business that can achieve scale, because it will make utilities money, because utilities will have an opportunity to share in some of the savings. This company, Seal, will make money, and we're going to have a lot more customers that will have more comfortable homes and save money. And if it turns out to really take off like this, we won't have to add to customer bills to fund the program. So I hope you have a flavor of how changes in policy in New York State will remove those barriers that stand in the way of clean technology coming to markets. And it's going to create the virtuous cycle that we've been looking for. We talked in the last panel about the ecosystem. So this is a cycle that means lower costs, and lower costs means more scale, and so forth, and it means that all costs, lower costs that will come from manufacturing scale and further innovation from a bigger economic prize, but also reduce soft costs from customer acquisition and installation, reduce cost of financing as more financing products get to scale too. So all these costs will go down and scale will increase. And it will create the ecosystem to promote manufacturing because of the relationship between markets and development of markets and the feedback loop from markets to manufacturers to the great universities that are in the state to the supply chain and to creation of skilled workers. So what do these policies mean for others? Because this is great for clean energy companies, but what's it going to mean for other companies that are in New York State and how they can help them become more competitive? Well, first, let's talk about the company's power bills, because we're on a path now where those power bills are going up and up. And under REV, it will produce a more economically efficient power system that will be more affordable over current approaches. And it will be more affordable because the system will be more capital and energy efficient, and it will be more affordable because we can reduce the extra charges that the government has been adding to support clean energy policies. But second, our policies will encourage companies to make investments in their energy systems because, depending on location, these systems can provide services to the grid as a whole. They can be another little way to make money. As an example, many companies have considered installing CHP or fuel cells, but face difficult interconnect issues or standby charges. And of course, under the old regulatory regime, utilities have no financial incentive to integrate such a distributed resource. But under our new policies, they will. Companies will have the opportunity to get paid, not just through participation in wholesale markets, for example, from demand response, but also from helping utilities manage the local grid more efficiently. So I worked in the private sector, and I've been to many meetings where people in the private sector say, government doesn't get it. We get it. Governor Cuomo gets it. However, getting these policies to work requires meaningful change in the business model culture and attitude within utilities, third parties, and government. And we really need your engagement to help make these changes, because it's really worth the effort. Because states, as Justice Brandeis said, are laboratories of democracy. And REV has gotten national attention. And if we can demonstrate how it's possible to remove the barriers to greater adoption of innovative energy technology and create scale in New York State, if it can happen in New York State, it can happen everywhere. Thank you.
Yeah, my goodness. My name's Bill James with JPods, and we've got a factory up in Poughkeepsie. I'd like you to stop by, and it built the solar collectors over MetLife Stadium. Great. But this shifting to a distributed model is what we're doing with JPods, which is a transportation system. I don't know if you're familiar with the Personal Rapid Transit Network in Morgantown, West Virginia. No. All right, it was built as a solution to the '73 oil embargo and has delivered 110 million oil-free, injury-free passenger miles. So Hyperloop is building in Slovakia and France because they can't build in the US. Mm-hmm. I'm going to India on Sunday to sign agreements to build there. And in China, I was there 2 weeks ago. And if we can build these networks here, we can make transportation a catalyst for achieving your distributed grid.
Yeah, thank you. So I guess a couple things quickly in reply. I mean, the first thing is, what we're trying to do in New York State is deploy distributed solutions in locations where the distributed solutions will have the most value for the system. And, you know, so when you think about Nevada, say, where there's been fights over net metering, we actually have a situation in New York State where the solar industry and the utility industry have come to an agreement on a successor to net metering because of the notion that we want to have move towards locational pricing. So it's not just distributed, it's having distributed solutions in locations which have value. That's the first thing. The second thing, and the point about communities, is really, really interesting. Because communities, when I talked at the beginning about changing customer preferences, we see across the state communities having tremendous interest in having more control over their energy system. So after several storms, the governor and I were listening to communities talking about how they were going to rebuild after Sandy and Irene and Lee. And communities said, well, you know, we'd like to have more control over our energy. And so the governor loves competitions and says, well, can you put some money together for a prize? He loves prizes too. And so we came up with a community microgrid prize. And we thought maybe a couple dozen communities would be interested in and we got 150 communities, and we funded just for a feasibility study, 83. And it looks like some number of those projects are going to be financeable without any further government support. And the last thing about communities is that when communities think about stuff, they're not just thinking about energy, they're thinking about transportation, and they're also thinking about broadband. And one of the interesting things is when you overlay areas of grid constraint over where there's not high-speed broadband, there's almost a complete overlap. And so communities, if they're going to be competitive, they're going to need to have high-speed broadband, and then there's a question about how do you think about the broadband infrastructure helping the energy infrastructure and vice versa.
Hey, Richard.
Is this going to be a hard question?
No,
Doctor?
but it's a pivot question.
Okay.
So you guys have played a real leadership role nationally in the state of New York in terms of supporting scale-up manufacturing of clean energy technologies, 1366, Solar City, Syrah, and others. And I was wondering if you could shed some light onto how you and the governor are kind of thinking strategically about how to position yourselves as a leader in clean energy manufacturing.
Well, so Frank is here, so I have to be careful. Frank von Mierlo from 1366. Look, I think that it's about, we really think about this as an ecosystem, because I think that I'm probably going to go off book here and get into trouble. But you know, one of the things I worry about in government is that when it comes to manufacturing, it can be a race for the bottom, because companies can go around and just ask for more and more subsidy. And that's not going to get us to where we need to get to, because if we're in an environment where we have to also try to reduce taxes, and then with the limited revenues, we also have to then give support, it really doesn't build the kind of society and communities that we need. So we really think about this in the way I think all of you think about it. We think about the ecosystem. So we have a limited amount of public dollars. How can we use those public dollars in a way where it has a connection to something else? So is the company going to be connected to the rest of the supply chain? Can the company be connected to markets? Can the company be connected to the skilled workers that we have? And that's how we want to align to universities. That's how we want to align things so that we support the manufacturing companies that have the best chance of success, and they're not just here because they've got a subsidy, because then they're not going to be able to really stay here. I mean, long-term competitiveness has to be more than just getting a government grant.
Just as a follow-up to that, I think we're here, one of the things we're talking about are these manufacturing institutes that are going on. I think one of the interesting phenomena, I want to comment on this, New York's been a big part of this, to say, instead of as an economic development package trying to land that one big company, sort of land the whale, it seems that governors now are getting the message saying, hey, if we can wind up getting one of these ecosystems to be here, you've got the Integrated Photonics Institute, you've got CPC and the Composites Institute working out on Long Island, then you've got the foundation for this whole ecosystem as a result of it, and the state's role on that. I wonder if you could comment a little bit.
Well, so this is how I think I got my job ultimately with the governor, because I talked about aligning the food chain. And that's probably the wrong analogy, because I guess a food chain, one animal eats the next. But it's really the idea that you have to align things from market development all the way back through to innovation. And that's where government, can really play a role when you think about the different resources the government has. Because you can hear through the regulatory stuff I've just talked about, we can change and create markets. There are other things that we can do. When we talk about NYSERDA, we have public dollars that we collect from ratepayers that we can try to use. David talked about the Green Bank. I don't want to talk too much about the Green Bank, but the point about the Green Bank is that when I talk about financing, is that the Green Bank doesn't provide subsidy. It works in collaboration with private sector entities where there are gaps in financing markets. And there are surprisingly gaps in financing markets. So that's an example where what government can do, government can lower soft costs so we can create markets. State government is not going to have, we're not going to have influence on lowering the cost of wind turbines or solar panels, but we can have an influence on lowering soft costs. So we didn't invent, for example, the solarized program, but we got 30 some odd solarized programs. So we can lower the cost of customer acquisition. We can lower the cost of financing by making financing available where it isn't otherwise available. So all along the way, government can play a role, and it's trying to have consistent policies across the different agencies of government to align. I don't know. Somebody has to come up with a better term for me. Align, the value chain, I guess. Okay, I just got the hook. Okay, thank you very much.